Imagine over 2,000 years ago in ancient Egypt, during the summer solstice when the daylight hours are the longest, the sun hung hot and high in the sky at noon. In the southern Egyptian city of Sienne, something miraculous happened. Sunlight streamed straight down into a deep well, illuminating the bottom, and the pillar on the ground cast no shadow. Meanwhile, hundreds of kilometers to the north in Alexandria, the sun at noon still hung at an angle in the sky, casting a distinct shadow. This unusual contrast piqued the interest of a Greek scholar. He was none other than our main character, Eratosthenes. Eratosthenes was born in the Greek colony of Cyrene, which is modern-day Libya, where he studied in Athens, immersing himself in books and developing a broad range of knowledge. He mastered mathematics, astronomy, geography, and was also a poet and historian, truly a polymath of his time. Known for his wide-ranging interests and his relentless pursuit of why, Eratosthenes was like an ever-curious child. In 245 BCE, at the invitation of King Ptolemy III, he became the chief librarian of the Library of Alexandria, the greatest knowledge center of the ancient world. Surrounded by books, he constantly stumbled upon fascinating ideas, and questions like, "Why does this happen, and how can we know the answer?" kept bubbling up in his mind. It was this burning curiosity that led him on the remarkable journey to measure the earth. As the librarian of the library, Eratosthenes had access to information from all over. One day he learned of the unusual phenomenon in Sienne where there was no shadow at noon on the summer solstice. Imagine this. On the day the sun directly strikes the Tropic of Cancer, which is around June 21st, the summer solstice, the city of Sienne happens to be right under the sun's direct path. As a result, the sun is almost directly overhead, even illuminating the bottom of wells, and vertical objects cast no shadow. This news amazed Eratosthenes. He thought, why does Sienne have no shadow at noon while we here in Alexandria do? For a scholar with an insatiable curiosity, this was like a sweet puzzle. Eratosthenes realized that there must be clues about the shape of the earth hidden in this mystery. He decided to embark on a scientific exploration to solve this shadowless mystery. At the time, many Greek scholars already believed the earth was spherical, not flat. A century before Eratosthenes, philosopher Aristotle had provided several pieces of evidence for the earth's spherical shape, such as the curved shadow of the earth on the moon during a lunar eclipse, and the phenomenon where distant ships' masts are seen first and the hulls last. Eratosthenes, being aware of these ideas, boldly hypothesized, the earth is a sphere, and the sun is so far away that its rays are nearly parallel when they reach the earth. Only under these two assumptions could the difference in the direction of sunlight at noon in Sienne and Alexandria be explained. Because the earth's surface is curved, the sun can be directly overhead in Sienne, but in Alexandria it would be slightly off-center, casting a shadow. If the earth were flat, or if sunlight were not parallel, there would be no such phenomenon of one place with a shadow, one place without a shadow. With his hypothesis in hand, it was time to test it. Eratosthenes set up a simple yet ingenious experiment in Alexandria. He chose the day of the summer solstice, when the sun is directly overhead at noon at the Tropic of Cancer, to observe the difference in the angle of the sunlight. Legend has it that on this day, he set up a vertical stick, or used the gnomon of a sundial, in Alexandria, and carefully observed the length of the shadow at noon. Sure enough, unlike Sienne, Alexandria's stick cast a distinct shadow at noon. This proved that the sun was not directly overhead in Alexandria but was slightly to the south. Eratosthenes then measured the angle of the shadow. He found that the angle between the sun's rays and the vertical stick was about 7.2 degrees. What does 7.2 degrees mean? A full circle is 360 degrees, so 7.2 degrees is approximately 1/50th of the circumference of a circle. In other words, Eratosthenes discovered that the difference in the direction of the noon sun between Alexandria and Siena was about 1/50th of the circumference of a circle. With the angle of the shadow determined, the next step was to measure the distance between Alexandria and Sienne. After all, to calculate the Earth's circumference, we needed the actual length of that arc. Interestingly, Eratosthenes did not walk the 800 kilometers from Alexandria to Sienne with a measuring tape. No one could carry a measuring tape that long back then. How did he know the distance between the two cities? Fortunately, ancient Egypt had professional surveyors, and caravans that traveled between the two cities for tax collection and trade had a general idea of the distance. It is estimated that the distance between the two cities was about 5,000 stadia, an ancient Greek unit of length roughly equivalent to 185 meters or 607 feet. This works out to about 800 kilometers in modern units. Eratosthenes likely estimated the distance by consulting travelers from camel caravans. These ancient travelers might have counted their steps, used the time it took to travel along the Nile, or even estimated the number of days it took to cross the desert. Whatever the method, Eratosthenes arrived at this key data point. Now everything was set. The angle was about 1/50th of the circle, and the distance was about 800 kilometers. Using proportional calculations, Eratosthenes quickly determined the Earth's circumference, about 800 kilometers times 50 equals 40,000 kilometers. In his units, this was about 250,000 stadia. This was his estimate for the waistline of the Earth. What's even more impressive is that Eratosthenes' calculated circumference was very close to the actual value determined by modern science. Modern measurements show that the Earth's equatorial circumference is about 40,075 kilometers, while Eratosthenes' estimate was 40,000 kilometers, less than a 2% difference. That means over 2,200 years ago, using only simple tools and the knowledge of his time, he measured the size of the Earth with astonishing accuracy. This level of precision was nothing short of miraculous for his time, and it's no wonder his name remains etched in the history of science. Eratosthenes' achievement in measuring the Earth's size had a profound impact on future generations. First, in geography, he pioneered the scientific method of understanding the Earth. In fact, Eratosthenes also created a world map and introduced the concept of latitude and longitude, earning him the title Father of Geography. With the crucial data of Earth's circumference, ancient people could create maps, calculate long-distance travel, and plan sailing routes with more precision. Second, in astronomy, knowing the size of the Earth meant understanding its scale in the universe. This laid the groundwork for later calculations of the Earth-Moon and Earth-Sun distances. Without Eratosthenes' measurement, astronomers would have lacked a key reference value when calculating planetary orbits or the movement of the Earth. Finally, in mathematics and scientific methodology, Eratosthenes' experiment showcased the power of geometry. He broke down a seemingly impossible problem into simple angles and distances, using proportional calculations to find the answer, an excellent example of applying mathematics to real-world situations. Eratosthenes' story teaches us a valuable lesson. Academic knowledge is not just for exams, it's a tool to help us understand the world. Without his curiosity, he wouldn't have explored the shadowless mystery. Without his observational skills and imagination, he wouldn't have thought of using shadows and distance to measure the Earth. This ancient curious child demonstrated through action that as long as we maintain curiosity, ask why, and apply the knowledge we learn in the classroom, we too can solve many mysteries of the unknown. Perhaps the next great discovery will emerge in that moment when inspiration strikes. Friends, let's start now with a keen eye for observation and a passionate thirst for knowledge to explore this wondrous world.